So welcome. Just to let you know, this recording will be available on the site, and if you have signed up to our newsletter, the recording will be available on the next newsletter, which will come out at the beginning of October. So please do sign up for our newsletter, where you can get information about all of our events and recordings of last events and lots more information. So I would like to introduce, well, it's an absolute pleasure to have Dr. Morris speaking for us today. I'm not going to tell you too much about Dr. Morris, because I think she's going to let us know about what she does in much better detail than I can tell you, but she is a senior lecturer at Loughborough University, and she's going to let us know about exercise and cancer. And I'm very much looking forward to hearing a scientist talk about this subject. I see some people here did come to our exercise and cancer event that we had before. This is going to be a very different event. It's about the science of exercise and cancer. So without me going into too much detail, I'm over to you, Dr. Morris.
Thank you very much, Shara. Thank you very much for inviting me to speak. So as Shara just said, my name is Barry, Dr. Barry Morris, and I'm a senior lecturer at Loughborough University. So my screen's not working. Hold on a second, there we go. So my background is in tumour virology. I did my PhD at the University of Birmingham, and then my research area was in a virus-associated cancer. So I was working on a very, very rare, like 1 in 100,000 Southeast Asian people would get this cancer. And then when I moved to Loughborough in 2017 and I joined the School of Sport, Exercise and Health Sciences, I was strongly recommended to find a sport and/or exercise angle to my research. And I have to admit, this opened up a whole new world for me, because I had awareness of the role that certain dietary factors and certain environmental toxins had in causing cancer, but I had no idea the powerful benefits that lay in living an active lifestyle. So I'm based in the School of Sport, Exercise and Health Sciences, and we're based in the building called the National Centre for Sport and Exercise Medicine, which is a bit of a 2012 Olympics legacy for our university. And we do a lot of work around the benefits of physical activity and exercise and nutrition in well-being and health. I'm also a senior fellow of the Higher Education Academy, which basically is an award that tells me I'm good for teaching. And I'm also the school equity, diversity and inclusion lead for learning and teaching as well. So I've got a real passion for trying to break down complex subjects and try and make them more easy to understand, which is why I think, yes, I am a scientist, and I will give you the science behind exercise and cancer, but I'm going to try and break it down and simplify it as much as possible. So I wear a lot of hats, many of them much better fit than this one on my graduation day. This was me in 2009 when I graduated from the University of Birmingham with my PhD, and the hat was huge and kept falling down over my eye. But it's something a little bit unusual about me is that I'm also a Les Mills dance instructor. So just this year, Les Mills, the group exercise company, now they're a global company, you've probably heard of them, you've probably heard of things like Body Pump and Body Balance and Body Combat. Well, they launched a new program in 2024 called Les Mills Dance. And I qualified back in March, and this photo was taken last Wednesday on National Fitness Day with my club down in Broughton Athley. I used to be, so the background to me is I used to be quite obese, very sedentary, and I was basically in my late 30s careening towards a lifetime of morbidity and ill health. And I found dance with a previous program called Shabam, and I fell in love with movement. It was exercise that didn't feel like exercise. And it's really ignited a passion in me to try and share that love of movement and get people moving again. Because I know how easy it is as a working mother and as you've got all these different hats you wear. You're a wife, a sister, a daughter, lots of things to do. It's very easy to let your own self-care and physical activity slide. It's very hard to squeeze it in when you get home from work and you're very tired. So that's part of my background. So tonight we are going to be looking at the role that exercise plays in cancer. But I'm going to start with looking at the role that our immune system plays in the whole cancer realm and how important it is. We're going to look at how exercise can be used to help patients as they undergo and go through their treatment for cancer. I'm going to look at the importance of exercise right throughout the cancer continuum, right from early diagnosis through to hopefully preventing secondaries. I'm going to take a little delve into the science behind what happens to cancers when we exercise. And we're going to take a little look at how exercise can affect the environment that's around the tumour. We call it the tumour microenvironment. I'm going to give you a little, peel back the curtain a wee bit behind some of the research that we're currently doing at Loughborough University. And then I'm going to talk about how exercise can actually improve immune function. So we start at the beginning with the role that our immune system plays, and then we wrap it all up with how exercise can impact that. And then I'm going to finish with some current recommendations for exercise. So these are the current recommendations from the American College of Sport Medicine, who are the gold standard. They're the leading authority in this area. I should say there is a chat box here. So if you have questions as we go through, feel free to open up the chat box and type in your questions. I've got it open on the other screen, but if I miss it, and Shara, you think it's particularly important and you want to interrupt me, please do. I'm not fussed about that. I'm quite happy to field questions as we go. I also acknowledge I have a very strong Scottish accent and I speak quite quickly. I will try my best to speak slowly, but if at any point you're thinking, oh, no, you're going too fast, please pop in the chat, and I will do my best to try and slow down. All right, so let's start with a little bit of background information on the immune system and cancer. So I don't really know your background, don't know your level of knowledge of the biology of cancer. And so if I appear to be really simplifying it and you're thinking, oh, I know this already, I do apologize, but I wanted to make sure that everyone's on the same page and is able to follow what I'm talking about. So we have two broad arms, if you like, of our immune system. We have the non-specific immune system. That's what you're born with. It doesn't change throughout your life. It's things like your skin is your first line of defense, the mucosal surfaces lining your nose and your throat that trap germs on the way in. And then we have our specific immune system, which is the stuff that changes in response to whatever pathogen you might meet throughout life. So when you catch a cold, your body mounts an immune response. It learns what that cold virus looks like, so that next time, if you ever catch that cold again, you will mount a response much more quickly. So the first cell type that I want to introduce you to are natural killer cells. And these are part of our non-specific immune response. And I liken them to Daleks from Doctor Who. Now, I haven't actually seen Doctor Who since I was a child. I think Sylvester McCoy was the Doctor. That's how long ago it's been since I've watched Doctor Who. But I'm sure you're all familiar with the notion of a Dalek. They roam around and they are looking for signs of trouble. And when they see something they don't like, they exterminate it. And our natural killer cells, or NK cells, are like Daleks in our bloodstream. So they're constantly flowing around the bloodstream, looking for signs of damage or danger. And they recognize cells on the basis of certain receptors that they have on their surface, and they have a kind of secret handshake, if you like. So if they meet a healthy cell, then what will happen is the handshake they have is between their inhibitory receptor and the healthy cell, whatever receptors they're expressing on the surface. And so what happens when they have that inhibitory receptor engaged is they don't receive a signal that says this is a dangerous cell, let's get rid of it. And so that healthy cell is allowed to live and they pass on to the next cell. So then, let's say a natural killer cell comes across a tumor cell, for instance. Instead of engaging these inhibitory receptors, this time the tumor cell will have a different handshake with the NK cell, and it will activate these activating receptors. And now the NK cell receives a signal that says, okay, this cell is bad news, we don't want it to live, and so it will secrete, it will kill the cell, and it does so one of two directions. So first is directly via its cytolytic activity, cyto from the Greek word cell, and lytic meaning to burst. So it literally causes the target cell to burst. And it does so by secreting proteins called perforins that land on the surface of the target cell and cause a little pore to appear. And then they secrete an enzyme called granzymes, which get in through this pore and break down all the structures inside the cell. And eventually the cell bursts and dies. Or it can do so indirectly. And it does this by secreting a bunch of proteins called cytokines, which are like these tiny, tiny little growth factors, which actually almost act like a homing beacon, recruiting other cells, such as cells from our specific immune response, come along and help kill off these target cells. Now, your natural killer cells generally recognize one of two cell types. The first is a cell that's been infected with a virus. So if you ever have caught a cold, then your NK cells would be the first cell in the system, the first cell in the immune system to that site to help kill off these virus-infected cells. But the second cell type that natural killer cells target are typically rogue tumor cells. So these could be very early stage tumor cells that have started to mutate their gene expression profile. They've got different markers on their surface, and these NK cells will recognize them as bad news and kill them off. And as I said, we have these two arms to our immune system, and the second arm being the specific immune response. So this is where you meet a pathogen, your body mounts an immune response, so that next time that you meet that pathogen, you respond a lot more quickly second time round. And there's two cell types I want you to know about here. The first are cytotoxic T cells. The T cells come from your thymus. Your thymus is a small organ about the size of your fist, probably a bit smaller, that sits in your chest behind your sternum. And you also have helper T cells, which are another type of T cell, and B cells, or B lymphocytes, which come from your bone marrow. So if you were to chop your bone in half and look down it as a cross section, all that spongy structure in the center, that's your bone marrow. That's where we get our B cells from. And these B cells actually serve to produce antibodies. And I'm sure you've heard of antibodies. Certainly a lot of chemotherapy or a lot of cancer treatments can be immunotherapy, where we have monoclonal antibodies against a specific antigen. Well, what our B cells do is, let's say we have a cell that has, now this is actually a virus, but imagine it's a cell and it's expressing these different proteins on the surface. The antibodies, the Y shape is very specific to that particular protein. And so when it then is secreted by our B cells, we have hundreds of these antibodies in our bloodstream, they'll flow around and look for other things in the body that express this protein. And if they find another cell or a bunch of cells that express this protein, they'll stick to it. And it almost acts like, again, a homing beacon, or like they're waving a flag to say to the rest of the immune system, come along over here, we need your help, let's get rid of this. So that is how our immune system helps to get rid of cancers. It's quite a fairly new, not brand new, but a fairly new field, because for years everyone thought cancer was caused by genetic mutations, which it is. But we also know that our immune system plays a really important role in keeping cancer at bay. Now, this study was published by a Scottish group from the University of Dundee in collaboration with some people from France. And they had a look at about 2 million different cases of cancer. And they saw that you get the rise in disease incidence actually correlates really closely with the shrinkage of our thymus. So they call this process is called thymic involution. So we're going back to this structure here that's about the size of your fist behind your sternum, and it produces our T cells. When you're born, it starts to grow, and by the time you hit about 18 months, maybe 2 years, it's the largest it'll ever be, and then it starts to shrink. And it shrinks on average by half every 15 years, 17 years, something like that. So by the time you learn to drive or go up to university, say, your thymus is actually half the size it was when you were a little toddler. Now, that rate of shrinkage does slow down over time. By the time you're kind of mid-30s, early 40s, it starts to slow a bit. But this is why, as we get older, particularly people in elderly years, our immune systems are not as strong as they once were. You're more prone to infections, but it also means you're more prone to developing cancer, unfortunately. So this group from the University of Dundee, they plotted that rise. I just want to point out to this right graph here, the rise in disease incidence with age, which of course correlates with declining immune function on the left-hand side here. And they actually were able to pick apart differences in gender as well. So we know that men, for example, have a slightly shorter than average lifespan compared with women. And they were able to pick apart these differences much more closely than they were able to correlate with the genetic two-hit hypothesis that we know and love. So we know that yes, cancer is caused by genetic mutation, but it's actually kept at bay for a majority of the time by our immune system. So I want you to hold that in your mind as we move on to the role that exercise might play. And we take a little sip of water here. So what evidence do we have so far for the benefits that exercise has in cancer? Well, in patients who are undergoing chemotherapy, it actually helps augment the effectiveness of the treatment because it increases or enhances their vasculature. So I want you to take a look at this image on the left under where it says healthy tissue. It's a very cartoon image of what your blood vessels would look like in your tissues. And healthy tissue has a nice regular structure blood vessel network. If you were to take a cross section through your blood vessel and look down the barrel, as it were, this orange circle in the middle, that's meant to be the blood vessel. So there's nothing in there except blood flowing up and down. The orange cells lining that, these are your endothelial cells that line the blood vessel. And then the yellow and green around that, we have smooth muscle cells and some basement membrane. So these smooth muscle cells are constantly expanding and contracting, and that is what helps your blood get pumped through the blood vessels. Now, in a tumour, as a cell grows and divides, so you'll have 1, becomes 2, becomes 4, becomes 8, and it happens very rapidly. Quite quickly, you're going to have a lump of cells that have no blood vessels in the inside. And so the cells become what we call hypoxic. So they have no oxygen. That also means they can't get any food in the form of growth factors and such like from the blood. And so these cells that are hypoxic, they can survive for a short while, and actually cancer cells are able to evolve in such a way that they can survive for a bit longer than healthy cells can without any oxygen. But they can only go so far, and eventually they're going to need blood to be able to get that oxygen and nutrients. So what they do is they grow their own blood vessels. The process called angiogenesis, and they do it very hastily. And my mum used to always say to me, less haste, more speed, Barry. And it's the same with cancer cells. They rush into it because they want to make these blood vessels as quickly as possible, but they don't do a very good job of it. So what we have is a very irregular structure and these very leaky blood vessels. How exercise can help with this is when you exercise, these blood vessels that are all irregular can form in a more regular structure and allow, effectively, the chemotherapy to get right into that central part of the tumour. So those cells that can survive under hypoxic conditions for a short while, if we can get the chemotherapy right into the centre, we're more likely to kill off more of these cells. So that's number one. The second, and we're not quite sure what the mechanism behind this is, but it seems to be that people who exercise before and during their chemotherapy are able to withstand higher doses of chemotherapy. They have an enhanced drug tolerance. Now, it could just be that they are generally fitter and stronger, and therefore maybe perhaps psychologically stronger, able to cope with it more. We really don't know the mechanisms behind this, but there's two benefits straight off the bat for how exercise can be beneficial during the treatment of cancer. I just see a question in the chat there. So are men more likely to get cancer than women? Not necessarily. I don't know the exact numbers. There are obviously different types of cancers that men and women can get, but in terms of overall numbers, I think it's not much difference between the two. I think they might be more likely to get it earlier, so more younger, but we're talking a couple of years. It's not really a big difference. Oh, there we go. So I'll just shut that down. There we go. How can exercise help in the treatment of cancer? So there are lots of molecular things going on here, and I don't want to go into too much detail, but I do want to highlight a few things. So first of all, exercise can help reduce the number of sex hormones in the blood, particularly if you think about estrogen in women, breast cancer survivors. So estrogen is obviously produced by our ovaries, but when we start to go through menopause, that stops, that slows down and eventually stops. And instead, the body thinks, right, where am I going to get it from? And actually fat cells are a really rich source of estrogen. Now, estrogen itself acts as a growth factor. It helps to promote the growth of cells. And cancer cells are basically greedy and they'll take food wherever they can get it from. So as we go through menopause, and if anyone is in the audience is going through that or have been through that, you'll possibly know how difficult it can be to lose weight when you get, or how easy it is to gain weight, actually, is what I'm trying to say. When you go through that stage in life, it's because your body is clinging desperately onto these fat cells because it wants that estrogen as a source of food for the cell growth. But as I said, cancer cells can be quite greedy and they take the food wherever they can get it from. So exercise can help reduce that. It can also help to stabilize our levels of insulin in the blood, and also another similar protein called insulin growth factor, which helps, again, drive the growth of these cells. So exercise can help stabilize those two. But I also wanted to highlight these two, which I think are really important mechanisms by which exercise can help. So the first is inflammation and adiposity. So in people who are overweight or carry excess weight or obese, they typically tend to have what we call chronic low-grade inflammation. So they have lots and lots of inflammatory molecules in their bloodstream, and inflammatory molecules are, again, a source of food for cancer cells that helps promote their growth. And of course, adiposity, this point one, or adipose or fat tissue, stores estrogen, which cancer cells will use as a source of food. So exercise, by very nature of reducing adiposity and also reducing inflammation, can help prevent this growing environment for tumours. But then also immune function. So I'm going to talk to you about this in a bit more detail later. We know that exercise, moderate intensity exercise, so you don't even need to do high intensity, just moderate intensity exercise, can help to increase your numbers of and mobilize your T cells that kill off cancer cells, and your natural killer cells that kill off cancer cells, and your neutrophils, which help resolve this inflammation and the tumor growth as well. That's about as detailed as I'm going to get. So what about throughout the cancer continuum? I've drawn a little, or plotted a little line here, timeline, with the left and right being the beginning and end of life. If at some point a patient is diagnosed with cancer, they will generally, depending on the cancer they have, undergo surgery and or chemotherapy, sometimes immunotherapy, hormone therapy, something else. If they get to 5 years beyond the end of their treatment and they have not had cancer return, they fall into what's known as the survivorship pool. And then if it could be years later, we don't know, it could be that the cancer comes back. We call this a secondary recurrence or a metastasis. So exercise can help reduce primary cancer risk in the first place. We can actually, with more than 13 different cancers, that exercise can help reduce the risk of developing. It can improve a patient's response to chemotherapy. So I mentioned earlier on that they can withstand higher doses, but it also helps improve their response to chemotherapy. It can help them improve their recovery as well, particularly surgery. Getting a patient fit for surgery means that they are much more likely to be able to return to normal physical function much more quickly at the end. Excuse me. And we think, although we don't know for sure, because it's very hard to do these studies, we think it also reduces the risk of secondary recurrence. And that makes sense, because if it reduces primary risk, then why would it not reduce secondary risk as well? And I'm going to show you a few pieces of data later on. We see that it also helps reduce the rate at which cancers grow. So it makes sense for it to reduce secondary cancer risk. So what about, I don't know if any of you have ever tried to look up the literature around this field, and it is quite unwieldy. There's a lot of papers. So I had a very talented student a few years ago. His name is Jonathan. He's pictured here on his graduation day in 2022. So he conducted a systematic review and meta-analysis, looking at the role of resistance or endurance exercise interventions and how they could elicit long-lasting improvements. And he looked at various different side effects that cancer has. And what he saw was that we see a long-lasting improvement in global fatigue in breast cancer patients, but when they undertake both resistance and endurance exercise together. So this image here, this graph, if you like, is called a forest plot. And all I want to highlight is this line down the middle, and see the little points either side of that line. If the majority of the points sit to the right, then we're looking at an improvement. If they sit to the left, then you're looking at a reduction or a decrease. And then it's summarized by these diamonds at the bottom. So you can see that these two diamonds, no matter which way you slice this cake, will sit on the right-hand side of the line, which shows that we have an improvement in global fatigue in breast cancer patients. This is just one image from, or one figure from this paper. We have many. So that's in people, but what happens in vitro, and what happens to existing cancer when we exercise? So it's all very well saying, let's do some research in patients, but there are certain considerations we have to take in mind. Ethical considerations. So it's not right to say to one of the patients, we can't withhold treatment for one group just to do a study. We're all very different. How I respond to exercise will be very different from how you respond to exercise. We have different genetic backgrounds. We have different diets. We have different other things that can contribute to it. We might have more stress in our lives, for example. So in order to try and pick apart the differences that just exercise have, we find ourselves needing to do research in vitro or in mice. So we have an option of doing animal research, or we have the option of doing different cells. But we are not mice. For example, if I was to take a human tumour and put it into a mouse, I would see how that mouse responds, but I wouldn't necessarily understand how that human tumour is responding in the context of the tumour microenvironment, which we're going to talk about later on, because what our human tumour in a mouse has is a mouse microenvironment. It's got all the mouse cells around it. So there's that. But that is what a lot of groups do. So there's a very big group in Denmark that do a lot of work on mice. And they looked to see what happened to the growth and the spread of tumours in mice that were given access to a running wheel. So they took two groups of mice. One group were not allowed access to a running wheel, and the other group were. Now, they weren't forced onto it, but mice, by their nature, that's their behaviour, I guess they get a bit bored and want to do something, so they get on the running wheel. And those that were on the running wheel saw a reduction in the growth of the tumours that they were then implanted with by 67%. Now, you can see the graphs here on the left if you want, but you can even just see by eye, just looking at these images here, that we get a lot less tumour growth, a lot slower tumour growth in the exercised mice versus the control mice. Unfortunately, though, it didn't appear to reduce the size of existing tumours, either in mice or in humans. So we don't know. We know that exercise is good, but we know that it doesn't reverse the process. But that's in mice, and as I said, mice are not humans. So what do we do next? Well, we have an option of culturing cells in the lab. So this is an image of a tissue culture hood. I do this on a daily basis. So this Petri dish will have cells grown on the bottom of it in 2 dimensions. We call it 2D cell culture. And we can supplement the medium with all sorts of things to see how they behave. I wanted to put this image here to indicate that these cells are growing side by side, much like sardines in a tin. And although it's great, we can see lots of good information, and we actually have a lot of our understanding of what happens inside cells from studies that have been done in 2 dimensions from, say, the 50s onwards. But it would be like me saying to you, let's have a game of football, but you've got it all lie on your back side by side on the floor and you're not allowed to run around. It's possible, but it's not a terribly accurate depiction of what happens in a game of football. So when I show you these things, bear that in mind. It gives us some idea, but it's not perfect. So we can take a similar sort of study. We can take cancer cells grown in 2D in the lab, and we incubate them with normal serum, implant these into mice. We call these nude mice, so they actually lack that thymus. They can't produce any T cells. They have no anti-tumor immunity, and we see the growth of new tumours. Alternatively, we can take these same cells, and instead of growing them in their normal medium, we can supplement that medium with serum from people who've done exercise. And this is what we do in the lab. We get individuals onto an exercise intervention, maybe on a bike or running or rowing or whatever, and then we can supplement the medium with that exercise serum, take those cells, put them into a nude mouse. We get no or far fewer tumours. So we know from this study, and this is not done by us, we don't have an animal house at Loughborough University, but we know from this study that there's something that happens to us when we exercise that we secrete into the bloodstream that helps to slow that growth of tumours. So I wanted to look at the literature again, because again, it's lots and lots and lots of different papers, and it can be quite overwhelming. There's a lot of information. So we performed another systematic review and meta-analysis, which, as the name suggests, we systematically go through all the literature, and then we pull out the data and perform some statistical manipulations to look at what the overall picture is from all these papers. And this was work done by my previous PhD student. She's now, she's passed her PhD. She's now working at the University of Cambridge. Her name's MJ Brown, Marie Juliette. And so what she did is that she saw, again, look at the line. We've got the on balance, the diamond is to the left. So we see a reduction in migration of cancer cells that were cultured with exercise in exercise situations. They're all a bit different. So we saw a reduction in migration, i.e. the cancers don't spread as quickly. We saw a reduction in viability. In other words, they don't live as long. And we saw a reduction in proliferation. In other words, they don't grow as quickly. So we're seeing that in vitro, breast cancer cells spread more slowly, live less or for shorter, and grow more slowly in the presence of exercise. Oh, I'm going to come to this question in a second, if that's all right. But I'll come to it now. The question is, what is defined as exercise? Do you need to do cardio, or will gentle walking be good enough? Yes, absolutely. Gentle walking is good enough. So exercise is defined as an intentional activity that you do that raises your heart rate and ideally will get you out of breath. So a light walk is exercise, possibly more classed as physical activity. Physical activity is kind of the incidental movement that you do with everyday life. So gardening, housework, things like that would be classed as physical activity. And they both count. They both count. If you are doing something, you're not moving your body, you're getting your heart rate up a little bit, and you're mobilizing your immune cells, which we'll talk about shortly, then that counts. Absolutely. Good question. Okay, so let's look at how exercise affects that tumor microenvironment. So going back to my model analogy here. So we have our tin of sardines, we're trying to play football line flat on the floor, side by side. It's great, it's okay, but it's not perfect. Or what we can do is we can culture ourselves in 3 dimensions. So imagine a bunch of grapes versus a tin of sardines. That would be the difference, where you hold cells in this 3-dimensional structure where they have interactions with each other on all 3 dimensions, not just on the side to side. And this is what we do in the lab. That's not an image from our lab, by the way. We haven't got quite such amazing microscopy skills, or at least I don't. But here's a cartoon version of what it might look like. So a lot of people think that a tumor is just made up of cancer cells. And eventually a tumor will be mostly cancer cells, but there are lots of other cell types in that environment. And I don't want to overwhelm you or bore you with the detail, but there's 2 cell types I'm going to point out here. The first of all is stem cells. These pink ones here represent our stem cells. And we have different types of stem cells within this tumor microenvironment, but one of them, they're called mesenchymal stem cells. And when we went back to the literature, again, we're like, well, are they good or are they bad? We don't really know, because some people find them to be pro-tumorigenic, so they're promoting tumor growth. Others find them to be anti-tumorigenic, so they're helping to support actually the immune system. So what we did is we conducted another meta-analysis. Again, this was MJ's work as part of our PhD. And what we saw is that no matter where we got our mesenchymal stem cells from, they actually increased the migration and invasion of breast cancer cell lines in vitro, which holds up with some of the theories that we have around the cancer stem cell theory. Stem cells, by their nature, are able to become anything they like when they grow up, effectively, so they can change and they can shapeshift and they can morph. So if in the context of cancer cell can use that cell type and co-opt it for its own bidding and help promote its growth and invasion and migration. The second cell type I want to highlight here is the adipocytes. So you may be familiar with the Cancer Research UK advertising campaign from a few years back about obesity being the #1 cause of cancer in the UK. And part of the theory behind this is to do with estrogen. So I mentioned earlier that after menopause, we stop producing estrogen and instead we use the estrogen that's made by our fat cells, which is why it's so hard to lose weight and so easy to gain weight as you go through menopause, because your body is desperately clinging on to this source of estrogen. Now, fat cells, particularly visceral fat, so this is the fat that sits around your waistline, these fat cells produce a lot of estrogen. And cancer cells are able to, once again, co-opt other cell types to do their own bidding, and we call these cancer-associated adipocytes, or CAS. They're also a source of insulin and growth factors, which we talked about before, and often within the adipose tissue, you have other cells like macrophages. We have this kind of inflammatory environment. So going back to what I talked about earlier, exercise can help to reduce estrogen levels by reducing adiposity. It can help to stabilize insulin and reduce the number of insulin-like growth factors, and it can help to reduce inflammation as well. And there were a couple of recent studies that really caught my interest, which is where I'm going with my research now, that showed when you culture cancer cells with adipocytes or fat cells, you actually get a proportionate increase in the rate of cancer cell growth, which I'm showing you on this page, and the rate of invasion, which I'll show you on the next page. So this image here is an image of something called a colony formation assay. The simple test we can do in the lab to look at how well cancer cells grow. So you would grow them in a kind of jelly-like matrix. Imagine putting raisins in jelly and you know, but the reason can grow, right? So we would grow the cells in this jelly-like matrix, and then after a few days, fix them, stain them with a dye, and just look at how many black dots we've got here. So you can see on the very left-hand side, well, this is your normal rate of cancer cell growth on their own. You've got little colonies forming. So again, think back to your 1 cell becomes 2, becomes 4, becomes 8. After a few days, you can imagine you've got little colonies forming. And as you go across to the circles on the right-hand side, you can see as you add more and more fat cells, more and more adipocytes, you're getting many more colonies forming, i.e. these adipocytes are supporting the growth and promoting the growth of cancer cells. They also increase cancer cell invasion, and we measure this with an assay called the Transwell migration assay. So what I want you to imagine here is 2 buckets, but the top bucket inside the second bucket has got little holes in the bottom, and on the underside of that bucket has got a kind of sticky matrix. So any cells that grow and migrate and invade through these holes will then stick onto the underside of the bucket. And you can put whatever you like in the bottom layer to see what attracts the cells. But in the context here, what they did is they cultured them in the presence and absence of conditioned medium taken from fat cells. And you can see, if I just highlight these 2 columns, this is your control well, so just the cancer cells and how much migrates after 24 hours on their own. But in this column here, when they add conditioned medium from the fat cells, you can see you get many more cells migrating through those wells. So we know that fat can cause cancer cells to grow and also to invade more rapidly than without it. So this is where we're going with our research at the moment. We're currently conducting a study to see how exercise can help to prevent that adipose-induced breast cancer cell migration and invasion. What we've done is we've recruited, and this is also Jonathan's work from when he did his master's project with me. He recruited 12 individuals onto an exercise trial, and we split them into 3 groups. Every person did participate in each group. So the first group, they did nothing. So we brought them into the lab, we took their bloods, they sat still for 3 hours, and then we took their blood at the end. The second group, they had to do moderate intensity exercise. So we got them on a bike, cycling at 50% of their maximum oxygen output, or VO2 max. And then the third group, they did high intensity exercise, and this was really hard. I really should have thought of this better when we designed the study. We got them to cycle for an hour at 75% of their VO2 max. We had a man who did regular Ironman competition, and he said this was really hard. And I thought, yeah, we need to bring this down. So I'm not for a second suggesting that that's what we need to do. But we also made sure that they had a week in between each collection so that we had no kind of residual factors that might be confounding the results. And then we took their blood. So we took their blood immediately before they did any exercise, immediately after they'd done it, and then they sat for 3 hours, and then we took the blood again. And then what we do with their blood is we spin it down and we separate it out and we extract the serum, which we then use to supplement our culture medium, and we use it to grow with our little 3D tumor spheroids. So going back to our 3D model. And we know from this study that it can help to reduce the growth and the migration of these spheroids. I just want to highlight this right-hand graph here. This top line is before they started exercising, and these bottom lines is all the immediately post 1, 2, and 3 hours post exercise. So you can see that high intensity exercise and moderate intensity exercise does have a reduction, but with high intensity exercise, it was significant. And what we're looking to do now is to see if we co-culture these tumor spheroids with the fat cells, do we see any difference in this? Do we still see a reduction in the growth and migration? Or is it like an immovable man meets an unstoppable object? Okay, so I'm going to move on to go back to our immune function. So remember right back at the beginning, I talked about our 3 different cell types, but those Daleks, those NK cells, and our T cells, which are killer T cells. So we know that patients who have more of these natural killer and particularly killer T cells or cytotoxic T cells typically have a better prognosis than those who have lower levels. So those who have lower levels would be, for example, those who are struggling with immunocompromisation, could be caused by chemotherapy, could be caused by the cancer itself, could be caused by another autoimmune disease they have, for example. But we know that in patients who exercise, it actually mobilizes their NK cells and their killer T cells. So we know that exercise is good because it helps them to withstand those higher doses of chemotherapy. It helps to enhance the vascularization of the tumor, but it also mobilizes these anti-tumor immune cells. Excuse me. And it's these natural killer cells, these Daleks, that are particularly sensitive to exercise. They are our first immune cell type to be immobilized following an acute bout of exercise. And this is because they express on their surface receptors for these catecholamines, adrenaline and noradrenaline. So you may know of and have heard of adrenaline, it's the fight or flight response. That's no different from when you exercise. It's one of the first hormones to be released. And these bind to these receptors on the surface of our natural killer cells, which causes them to be mobilized. Excuse me a second. Something's gotten back on my throat. We know that patients who have cancer and then participate in moderate intensity exercise have an increase in their numbers of NK cells, but also the killing activity. So we can do an experiment in the lab to look at the rate of how much or how quickly our NK cells can kill their target. And patients who participated in this moderate intensity exercise showed an enhanced NK cell activity. They see higher levels of lymphocyte growth, so your T cells and the B cells, should they grow more quickly. But what's interesting is that exercise appears to be most beneficial for patients who have got some level of compromised immune function in the first place. And if you think about this and just make up an arbitrary scale of 1 to 10, and let's say 7 and above is fantastic, your immune system in good nick, but 1 to 3 is quite low. You can imagine that a patient who's sitting at 6 is only going to see a small benefit with exercise, whereas a patient who's sitting down at the 1 to 3 level has got scope to see much more improvement with exercise. So I just want to finish probably the most relevant bit for you all. It's talking about the current recommendations for exercise in cancer patients. So what should you do? How much should you do? Is it safe to do? And so on. Now, I mentioned at the beginning the American College of Sports Medicine, or the ACSM. They published guidelines. The most recent publication was in 2019, but they fairly regularly update them. And they are the authority in this space. They have a whole team of researchers who review the literature, who look at this systematic reviews and the meta-analyses that have been published, and they pull out the guidelines from there. And what they recommend is 150 to 300 minutes per week, broken down into ideally 5 different exercise sessions of 30 to 60 minutes each of moderate intensity exercise, or if able to, 75 to 150 minutes or 15 times 15 to 30 minutes of vigorous intensity exercise. But what I would say is that unless you are already physically fit, doing vigorous intensity exercise, particularly when you're going through chemotherapy and treatment, it can be very difficult to do. So moderate intensity is more than sufficient. These are the recommendations. Again, caveating that with what's possible, you know, your own body. But I think this is hyperlinked, and you should be able to get this. If not, you can follow this link, this web address here, and Shara will share the slides with you at the end. So anything in here that is hyperlinked, you can just click through straight to it. But this is their summary diagram from their website, looking at the evidence for the effects or the benefits of exercise, on various health-related outcomes for those who are living with cancer. And I want to highlight a few things here. Both aerobic exercise and resistance exercise, or a combination of the two, there is strong evidence for this to reduce cancer-related fatigue, also global fatigue, to improve health-related quality of life, and improve physical function, so to get you back to your normal physical functioning post chemotherapy. And we're taking things like simple things like your grip strength, being able to pour a kettle, for example, being able to walk up and down the stairs. We have strong evidence for aerobic exercise, or a combination of the two, in reducing anxiety and depression in patients. And this actually goes beyond cancer as well. We know that exercise is really beneficial for reducing anxiety and depression in general. And interestingly, resistance exercise has been shown to be beneficial if patients are experiencing lymphedema. So often, for example, I keep going back to breast cancer because that's what I research, patients who have undergone a mastectomy and then potentially had a reconstructive surgery. If you've had any lymph nodes removed, that neighbouring limb is often suffers with lymphedema and swelling. And resistance exercise or progressive supervised exercise can help to reduce the swelling. Certain things will affect a person's ability to exercise, of course, the type and stage of cancer that they have, the treatment that they're undergoing at that time or have been undergoing, their baseline level of strength and fitness and their stamina. But I think what's most important is that people listen to their own body. You know your body better than anyone else. So you know on certain days you might not be feeling able to even do a gentle walk. Listen to that. But if on the days when you're feeling a bit stronger and you feel like maybe I can push myself a bit further, then, you know, again, listen to that. Just make sure you are not trying to push yourself too much and then set yourself back. And I want to also highlight this brilliant resource from the Moving Medicine Project. So again, I hyperlink this here as well. You can follow this through. They've got some wonderful resources. They're designed for GPs and health professionals, but actually I think they're great for the general public as well. If you want to start having a conversation with your GP or your health professional, then you know you can use these resources. They've got a series of questions based on how long you've got with them. If it's just like 1 to 3 minutes, or if you've got 5 minutes or more. But they have great infographics that talk about the benefits of exercise, but also ideas and tips for getting you active and getting you to build it into your daily routine. So basically, what I've talked about today, we know that exercise can slow tumour growth, but sadly doesn't shrink the size of existing tumours. We know that it's most beneficial to patients who already have some level of immunocompromisation, but that doesn't mean it's not beneficial to others. The Moving Medicine resource is a great resource to provide you with conversation starters to have with your GP and or your treatment team. The current recommendations for exercise are 5 times 30 to 60 minute bouts of moderate intensity exercise each week. And the outline recommendations, which I don't think I did say, but when you're returning to exercise after a spell of not being fit and active, is to build in gradual increases, phase it in gently, and gradually increase the amount of exercise that you do each day. Thank you very much for being here tonight. If you have any questions, please do share them. You can pop them in the chat, or I don't know, Sarah, leave it up to you how you deal with that.
Yeah, thank you. Wow, so much information. Thank you. I think I was actually a bit confused about one of your slides, but I think I figured it out now, and it was me.
Sorry.
So can I just start, just in case anybody else is confused? You've got a moderate intensity and a vigorous intensity, but actually I figured out that your vigorous intensity is supposed to be less because it's vigorous.
Yes. Yes.
Right. Okay. Because I'm thinking, why is it less if it's supposed to be? So I figured that out. So, so if you do vigorous intensity, it's 75 to 150 minutes a week, as opposed to moderate, which is 150 to 300 minutes a week. So if you do it, does that give the same result?
In theory, yes.
Yeah. So you can do moderate.
The notion that running a mile and walking a mile burns the same number of calories, we just take longer to walk it. So you get the same benefits from doing less vigorous, but vigorous intensity exercise. So
you don't really have to get your heart pumping a lot.
It'd be good to get it up a bit, so beyond your base level, but say 100, 120 beats per minute is sufficient.
Oh, right. Okay. Well, that's interesting. Are there any? I think there's so much information. It's difficult to know questions. And you had questions coming through. Does anybody else have any questions that you want to put in the chat, and I'll feed them to our speaker. Do you have? Where is your research going? What do you think you're going to do?
I'm really interested in the role that obesity plays. So I think that's where I'm going to be focusing for the next wee while. There's not really anyone looking at the crossover between exercise and obesity and breast cancer in an in vitro setting. So I feel like that's a nice niche to kind of set myself up in. I also think from a personal perspective, I'm really interested in that because I used to be obese, and just knowing the health benefits that exercise has had in my life. I think that I'm a bit of a geek, and I like the science and the cell signaling stuff that goes on behind the scenes. So I think that's where I'm heading.
And for me, as an ex-breast cancer an ex-breast cancer person who is 2 stone overweight, it just makes me think I need to lose some weight and exercise, which I know already, but I know that I do now. So that's really good, isn't
it? We all know you have to be living under a rock to not know that you have to eat well, maintain a healthy weight, and exercise regularly. but it's really hard to build it in. And for me, it's about
Yeah.
finding something that you love and enjoy that doesn't feel
Yeah.
like exercise. That was the key to get me off my sofa and down to the gym. Was finding something
Yeah.
that I love, and then finding a community of people that you get on with as well. That also helps.
And finding the time to do it, I guess, as well.
Yeah, but making the time to do it. We all have the same 24
Making
hours
the
in a day,
time.
but we all use it very differently. I have this
Yes.
conversation with my sister all the time. She's very inactive. Oh, I haven't got
Yes.
time, I haven't got time. I'm like, you do? I work full time and I teach 3 dance classes a week and I manage to find time to do it. So, you don't.
All right. All right. That's you talking directly to me.
No,
Find the
not at all,
time.
not at all. I
No,
just
it
think
is. You and my kids and my husband. I need to find the time. Yeah. Okay. So I don't know if we're going to have any questions. I think people are going to ponder a lot over your slides, which were, as I say, extremely informative. We've never had a talk like this before that's directly science, and I think it was fabulous. So thank you very
Thank
much.
you. I'm
Yeah.
always very aware that I'm very sciencey, but I try and kind of bring it down to the most simplest form.
I think it was very
I hope
understandable.
you followed it.
Yeah, no, I hope it was understandable, and I imagine that you're vaguely contactable in case it's
Oh
not. I
yeah,
know you're a
absolutely.
busy
So I have,
scientist and with your
yeah,
dancing and everything. So yeah, so well,
I have
lovely.
my
Thank you
email
very
on
much.
the page. So if anyone wants to get in touch, absolutely welcome to.
Right.